Hey guys, in this video we're going to talk about the algebra of functions and the composition of functions. So we're going to be looking at problems that look something like this, if hopefully that's the type of problem you were looking for. So just as a reminder, if you've never seen these videos before, you're going to want to pause and try the examples. It'll just make the video seem a little more meaningful to you. And if you'd like to try the guided notes, you can go to divideandconquermath.com and you can access them there. So let's just get started. So first we're going to talk about the algebra of functions. So these are like some of the function operations that we talk about when we talk about the algebra of functions. So let's pretend that I've got just two functions, f of x and g of x, and maybe I have some notation like this, so I'm adding them up. What does this actually mean? If you see this, what this means is that you just take whatever f of x is, and then you just take whatever g of x is, and you add them up together. So this is really a shorthand to represent writing out this. That's all this really is. So this would be a shorthand then for taking f of x minus g of x. Then for multiplication, so as you might imagine, you're going to multiply the two functions together, and maybe I'll just put a dot in between them. And then finally, if you have f over g of x, so then this is a shorthand for writing out f of x divided by g of x. And of course, g of x does not equal 0. Hopefully that is clear, because you can't have 0 in the denominator. So that's all that this really means. These are just kind of like shorthands, but what do you actually do with them, or what type of problems would come up with them? So I'll show you. So here I have a whole list of functions, f, g, h, and k. And so what I want to do is I just want to find the following kind of other functions. So this one says g minus f of x. So what would you do for this? So what you would want to do is first just write out what this actually means. I need to take whatever g of x is, and then I need to subtract f of x. Okay, so going up to my list, here's g of x, right? So I'm going to put some parentheses around this. So this is 5x minus 4, so there's g of x. And now I'm going to put parentheses around f of x, and f of x is x plus 2. Okay, so the first thing that you want to do whenever you are doing algebra with functions, you just want to write it down. Write it down, and then after you've done that, determine if there's anything else that you can do. So in this case, I can totally collect some like terms, right? So this will be, if I first distribute that minus sign, this becomes minus x minus 2. So then what you've got to do is just finish it. So 5x minus x will be 4x, and negative 4 minus 2 will be 6. So what this means is g minus f of x is equal to 4x minus 6. So this equals this. And this is all the operations that were really buried into this notation. So it's a shorthand for telling you what to do with certain functions. Okay, so now I want you to try this on your own. So now I've got k plus f of x. So I want you to write it out just like I did here. Write out what this means, and then write it out, and then just see what else can you do. Hit play when you're ready. So now I need to take k of x plus f of x. So this will be, let's see, this is 3x squared plus 2x minus 1 plus x plus 2. So now if I actually add these all together, I get 3x squared plus 3x plus 1. And that's all I can really do with that one. Maybe the only other thing I'd write is just k plus f of x equals this. So that's what the result is. So that's really the first part of this in some ways. Now, let's just look at two more operations just so that we're nice and thorough. So now what I want to do is I want to do h of x times g of x. So you know that you're supposed to take h of x, whatever that is, and then multiply that by whatever g of x is, and then just figure it out. So why don't you pause the video, try that, hit play when you're ready to see the solution. Okay, so if I take h of x, this is x squared minus 4, and then I multiply that by g of x, so that's 5x minus 4. So now I have to FOIL that out. That's really what I'm left to do, right? So if I FOIL that out, I get 5x squared minus, 5x cubed, not squared, 5x cubed minus 4x squared minus 20x plus 16. And so check it out. In this particular example, I can't collect any like terms, so I'm actually done, right? That's all I can do with that. Okay, now what about h over f of x? Same idea. Maybe pause, see if you can do it all the way. Hit play when you're ready. So this is, I'm going to take, sorry, I'm jumping ahead. I need to take h of x over f of x. So if I do that, that's x squared minus 4 over x plus 2. And now you might be thinking, oh, I can totally factor x squared minus 4, which I agree. So that'd be x plus 2, x minus 2 over x plus 2. So those x plus 2's will cancel out. So in this case, I'm left with x minus 2. Now, just a heads up, as far as like whether or not this is something that's always supposed to happen, will you always be able to cancel something out? No. It depends. So all of these just totally depend now, and you're totally flexing just what you know about working with functions and algebra in general. So anything goes. So don't just rely on, oh, I'm dividing, so I have to be able to cancel something out. Maybe, maybe not. Okay, so if you found this helpful so far, maybe consider liking my video or subscribing to my channel or leaving me a comment. I'm trying to grow this channel, so every little bit of support really helps. So let's keep going with this idea, and now I want to switch it up a little bit, and I want to show you just a couple other ways you could see these types of examples. So let's start with this one. So you should be good to go on this one. So maybe pause the video, work this out, hit play when you're ready. So I need to take f of x minus g of x. So if I work this out, so this is x plus 2 minus 5x minus 4. So that's x plus 2 minus 5x plus 4. So this will equal negative 4x plus 6. Okay, so here's, maybe I'll put a little box around this. Here is the result I got for this, okay? Now, pay attention to the next question. I'm asking, what is f minus g of 3? Okay, this now is going to be a little bit different, and you have to kind of think through what you want to do with this. So sometimes you're going to have numbers input here, and you have to decide what makes the most sense of how to approach this. Now, with A, so this is basically the same question, right? Except now the only difference is that I'm asking you to plug 3 in. So the thing is, if you know what f minus g of x is, which we do, you can actually just plug that number straight into this, okay? So we already have this knowledge, so we're going to leverage that. So what I'm going to do is I'm going to write out this, but I'm going to plug the 3 in, basically. And then I'm just going to work it out. So then this becomes negative 12 plus 6, so this equals negative 6. Okay, now hold that thought for a second. Now I want to pivot. So now I've got h times k of 1. So this is different from the last one because we don't know what h times k is, right? We'd have to figure that out. So you have two options of how you could do this. You could actually do h times k, and that would be maybe a little bit more work, but I want to show you, and that's totally fine if you want to do that, by the way, but I want to show you another way you could approach this. So remember what this actually means. This means I take whatever h of 1 is, and then I would multiply that by whatever k of 1 is. So I'd evaluate these two functions separately and basically just multiply out their results. So you have two options when you have numbers put into this. In the case of the last example, so here I knew what f minus g of x was. So it was faster and easier for me to just plug the 3 in here. But in this example, I don't know what h times k is, so I have to make a judgment call and say, what's faster? So to me, it seems like it might be faster if I just plug 1 into each. So let's go ahead and do that now. So why don't I do h in the pink color, and I'll do k in the yellow color just so you can track my work. So remember what h is. H is x squared minus 4. So notice how I just plugged the 1 into this. So I'm going to work that out in its entirety, and then I'm going to multiply that by this k of 1. So I'm going to use this k function here, and I'm going to plug in 1 into everything. So this is 3 times 1 squared plus 2 times 1 minus 1, and I have barely enough room there. Okay, so basically now you work out these two mini math problems, which these aren't too bad, right? So this is really 1 minus 4, so this will be This will equal really -3. That's what that equals. And then this one, this is going to be 3 plus 2 minus 1. So this will end up really being, this times, let me keep my color coding here. This comes out to -3, and this comes out to, so I said 3 plus 2 minus 1, so this is 4. So this is the other route you can take. You can plug that number into each function and then just multiply the two results together. That's what this is really asking you to do in this case. So this would equal -12. But you could have, if you wanted to, I personally think it's more work if you didn't have to do it before, but you could have taken x squared minus 4 times 3x squared plus 2x minus 1, figured out what that is, and then you could have plugged in 1. It's whatever you want to do. Okay, so now I've got one more of these for you, and it's kind of the same idea. So I have g over k of -2. So what I want you to do is I want you just to determine what you think the best approach is. Take your time with it, and then when you're ready, hit play to see the solution. Okay, so I need to take g of -2 over k of -2. And personally, I think I'm just going to go ahead and plug this into the top and bottom. It's not like working this out beforehand is going to really cut out that much more time. So I'm plugging in -2 to g, and then I'm plugging in -2 into k. So if you compare the two, you can see I've plugged those in. So this will become -10 minus 4 on top. And then in the bottom, this simplifies to 12 minus 8 minus 1. See, I'll fix that. So this equals -14 over 3. And that would be it in this case. I really can't do anything else with this one. So that covers that idea. So now I want to pivot to another idea called the composition of functions, and this is something a little bit different. So the composition of functions looks like this. Just to be nice and clear, because it's a little hard to make it look like this, this is a circle. This is not an O, it does not say fog, it's a circle. And what this notation means, this means composition. It means this, f of g of x. And I'll show you how to actually do this in a second. But the way that you would say this, you would say f of g of x, and then g of x has to also be in the domain of f of x. So this is a little circle, and it's giving you a very specific set of directions. And why don't we just jump into the example? Okay, so I have the same f and g from the example I was doing before, just so I can kind of show this to you. So I want to take f of g of x and evaluate what is that. Okay, so the first thing I recommend that you do is actually write out what the composition means. So it goes in order, f of g of x. From here, what you're going to do, you're actually going to start from the inside and work your way out. So here's what I mean. I've got my g of x here, and I want to now fill in this part. So if I do that, this is going to equal f of, now let me fill in my g of x, 5x minus 4. Okay, so now I have to think about what does this actually mean. What this is telling me to do is to now plug in wherever I see an x in my f of x, I now need to replace it with this 5x minus 4. That's what this is trying to get at, and that's what composition is asking you to do. So I'll show you how that looks now. I take my x plus 2, but where there was that x, so where you see that x here, now I'm going to replace it with this 5x minus 4 plus 2. So notice how the x now has been replaced by the inside of this. Now, once you get to this point, it's the similar idea as before. Just see what you can do. So in this case, all I can do is collect my like terms. So this becomes 5x minus 2 and we're done. All right, so now let's compare that to g of f of x. So like I said, the first thing you want to do here is write out the notation. So I've got g of f of x. So let's go through this together. So I'll get rid of these colors up here just to make it not confusing. Okay, so where I want to start is I want to start from the inside. So in this case now, my f of x is the inside. So I want you to pause the video and just plug in f of x so that you can see that and hit play when you're ready. So this will equal g of x plus 2. So now what that means is where there was an x in my g, so I'll underline that. So this now will go into the x position in the g function. So you're just going to make that replacement. So I want you to once again pause the video and make that replacement, and then hit play when you're ready to move on. So this will be now 5 times x plus 2 minus 4. So once again, notice here was where the x was, I replaced it with x plus 2. From here, now it's just a matter of what can you actually do. In the last example, I got to just collect like terms, but here now I have to actually distribute. So this will be 5x plus 10 minus 4, and so this equals 5x plus 6, and that would be your answer. Okay, so I have just a few more examples now just to help you out with this a little bit. So I have 3 new functions. So I have a new f of x, a new g of x, a new h of x. I want you to practice finding f of g of x one more time. Hit play when you're ready to see the solution. Okay, so now I've got f of g of x, so I now need to replace my g of x with whatever that function is. So this will become f of 3x minus 2. So I start from the inside and I work my way out. Okay, so now I basically need to plug 3x minus 2 into this function. So where there is an x, I will now replace that with 3x minus 2. So this will equal 4 times 3x minus 2. So you want to kind of quiet your mind here and not try to tell yourself to do too much until you get to that point. So here's my 4 times my x, and then also just make sure that you actually remembered the whole function. So this does look like I just plugged in the x, everything else is still intact. Okay, so now that I'm here, now I see what I can do. I can distribute. So let's see, I'll continue this over here because I'm running out of space. This becomes 12x minus 8 plus 1. And so this will be 12x minus 7. And so that would be your solution. Okay, so now I want to once again do something similar to what we were doing in the last exercises. What do you do when there's a number in here? So now I'm asking for something a little different, right? G of f of 2. So you could figure out what g of f of x is. You could go through and figure out that composition and then plug in the 2. Totally fine. But I just want to show you what you could alternatively do with this. So let's think about what does this actually mean. This means g of f of 2. This is what this is asking for. So look at what this is. This is really, I mean, you could even just like maybe cover up the g in the parentheses for a second. We have to figure out what is f of 2. That's actually where we have to start. So what I'm going to do is I'm going to replace this inside with plugging in 2. So we're actually going to kind of work out this like mini function to start. So notice how this is all of 4x plus 1, but now I replaced that x with a 2. So the first thing I want to do here actually is figure this out. So this is 4 times 2, which is 8 plus 1. So I want to replace this inside function now with the answer. So 4 times 2 plus 1 is going to be 9. So check out how this actually simplified things. I figured out what the numerical answer was for that. And now all I have to do is plug in 9 into my g of x function. So I actually don't have to do the rest of this stuff now. So if you have a number here, this is another way that you can kind of handle this. And now you can just kind of see it the rest of the way through. So if I plug 9 into g of x, this will be 3 times 9 minus 2, which is going to be 18 minus 2. Sorry, not 18, 27. 27 minus 2. So that equals 25. So that could be how you would handle something like that. So I have just 2 more of these here for you now. So if you want to pause the video and give them a try, then you can hit play when you're ready. Okay, so for this first one, so this is going to be f of h of x. So I need to start from the inside and work my way out. So h of x is x squared minus 1. So now I have to plug that into my f of x function. So this becomes 4 times x squared minus 1 plus 1. And so now I can distribute. This becomes 4x squared minus 4 plus 1. So my final answer will be 4x squared minus 3. Okay, and now for the one that's going to be a little bit of a plot twist here. So now I've got h of g of x. Now for this one, if I plug my 3x minus 2 into my h of x function, so notice this is x squared minus 1, so this will be 3x minus 2 squared minus 1, which means that I have to do what? What do I have to do here? I have to FOIL it out. So it is actually a little bit more work than you thought. Psych! So, all right. So I got to work all this out, right? So let's see. If I work all this out, why don't I clear this space up here just to give myself some more room? All right, so now I got a little more space. So let's see. This is 9x squared minus 6x minus 6x plus 4 minus 1. So if I collect my like terms, I get 9x squared minus 12x plus 3. And remember, this is all you're being asked to do. You're just being asked to figure out what happens when you compose them. You're not being asked to solve, you're just being asked to simplify. So in this particular instance, when you kind of put everything in, it just so happened that you had to FOIL it out. So anything's possible when you work with these compositions. So first you just want to make sure you've got everything set up, and then you kind of figure it out from there using all of the other algebra knowledge that you have. Okay, so that'll cover this particular lesson. So hopefully that was helpful for you. Please consider subscribing to my channel. I would really appreciate it, and I'll see you